I just interrupted for a second my video, and now I wanted to say this. So delta y is approximately dy. So treat this like an equation, and I am going to move f of x to the other side. So this is f plus, so since I have since they are the same, I'm going to be consistent and just use dx in both cases. Approximately f of x plus f prime of x dx. This is the most important relationship here towards the end of this chapter. So very important. You will always remember it if you understood what I just did here with the graph. If you want me to repeat any of this, please say so. Maybe now it's not, you don't have a question, but maybe next time you want me to repeat it. And now we're going to apply this in applications. So this is the exact change, and this is the change given with the derivative. The exact change and the change with the derivative. The exact, the differential. This is not the derivative of the function. This is the differential of the function, which is f prime of x times dx. And all I did was I added f of x to both sides. Okay, let's see how we apply this concept. And let's go to page 265. Where's my keyboard? 265. And enter. Will it do it? Okay, please enter. Okay. Very good. So let's take a look at what is called the marginal cost. And I'll explain the name of the marginal cost in a second. Okay, so let's start with number 3. So 3 on 265. So suppose that the daily cost in hundreds of dollars. So okay, producing X security system is C of X 0.002 x cubed plus 0.1 x squared plus 42x plus 300. And currently 40 are produced daily, 40 per day. What is the current daily cost? So we are given the cost function, and we're asked if we produce 40 units per day, and this is in hundreds of dollars, the cost. We have to remember that. So we're asked to find the cost for producing 40 a day. What do I need to do? Is anyone with me?
You plug 40 into C of X.
Thank you. That's exactly what I'm doing. Right behind your back, I was trying to put in the function without telling you. Just kidding. No, I didn't mean that. I meant this. I didn't finish. Okay, plus 0.1 x squared and plus 42x and plus 300. And second and table, and I'm plugging in 40. 2268, I don't think there is anything else there. Yep. So the cost of 40 is 2268. It's in hundreds. So 226,800. Okay. So next question. I didn't mean to stop sharing. I wanted to go here. What would be the additional daily cost of increasing production to 41 security systems daily? So additional cost is exactly what we just talked about, delta y. So now I'm not producing 40, I'm producing 41, which means the dx and the delta x are 1. That's if you want the so-called error or change. I no longer want to produce 40, I want to produce 41. So in order to produce 41, I'm really looking at a change of 1. So that's my dx. This is 1, this is 1. But I'm asked right now the exact. Since I'm asked the exact, I have to find this, f of x plus dx, f of x plus dx minus f of x. I already have f of x. That's my f of 40. But I want to find f of 41, 40 plus 1, the error, if you want. So then I have to find, cost of 41 minus cost of 40. This will be the additional cost if I decide to produce not 40 per day, but 41 per day. So back to sharing my screen and going back to the calculator. All I need to do now is plug in 41. So for plugging in, so I got, please make sure you copy the whole thing. So 2327.942 minus, and this is in hundreds. I cannot forget to do that, right? Okay, so it's 232794. Okay, minus 226,800. So let me stop sharing. So this is the difference. So 232,794.2 minus 226,800. Whatever that is the additional cost for producing 41 a day instead of 40. So 232,794 and minus 2268. Okay, so this is 5,994.20. Okay, let's take a look at part C. Any questions so far?
No.
Perfect. Okay, where is my book? Here. Okay, what is the marginal cost when x is 40? Okay, the definition of the marginal cost is simply the derivative function. This is the marginal cost. So they're asking us now to find C prime of 40. The marginal cost when x is 40. Okay, fine. You understand what they are preparing, right? So we have these, and they're asking us to find this now. Okay, so let's find C prime first. C prime of x. Okay, so 0.006x squared plus 0.2x plus 42. So C prime of 40. 0.006 times 1600, 40 squared, plus 0.2 times 40 and plus 42. 0.006 times 1600 plus 0.2 times 40 and plus 42. I'm just making sure. 1600, yep. So I got 59.6. Of course, this is in hundreds. So 5960. Okay, perfect. Last question. I think there is one more. There must be. Use marginal cost to estimate the daily cost of increasing production to 42. Okay. So use the marginal cost to estimate the daily cost of increasing production to 42. So now this is an estimate. To estimate. When we're asked to find exact, we have to find delta y. When we're asked to find the estimate, we're asked to find the approximation. So f of 40 plus 2 is approximately f of 40 plus f prime of 40 times 2. And this will be the approximation of the cost of 40 plus 2. So let's do that together. So,
You're still sharing your screen.
oh no, so sorry. Sorry about that. So let me show it again, sorry. So this is the formula we're going to use. So we're asked to find the cost of 42, of estimating the cost of 42. So this is approximately, so if this is 40 plus 2, this is approximately 40, f of 40, c of 40, plus f c prime of 40 times 2. This is the approximate. If they want the exact, then we have to find c of 42 minus c of 40. But they don't want that. They just want us to approximate. Use marginal cost to estimate the daily cost of increasing production to 42. So this is, we have c of 40. C of 40 was this, 226800 plus c prime of 40, we have it, 5960 times 2. Let's see what we get. 226800 plus 2 times 59960. That's it. So 238720. Is this exact? No. It's estimated. Using the differential of the function dy, we did not calculate the exact. We calculated the estimate. This is how we apply the formula. And I know we only have how many more minutes? I don't want to hold you over. I have 3 minutes. I just want to show you something, how powerful this is, this formula is. Hopefully I can finish it in 3 minutes. If not, I'll stop. Promise. Okay, so let's look at 39. 39 is the cube root of 105. And I just want you to see how powerful you are right now. It says find blah, blah, blah to 3 decimal places. Well, we can take the square root by hand. The cube root is a little bit more involving. But remember what we're using, f of x plus dx is approximately f of x plus f prime of x dx. So I know that the function is the cube root. So f of x is the cube root. X is exactly 1,000 because I can take the cube root of 1,000 and I get 10. And this is a minor error in comparison to 1,000. 5 versus 1,000, this is minor. So this is the dx, which is 5. Let's find f prime of x, which we know that this is x to 1/3. So x to 1/3, x to negative 2/3. And now we can approximate the cube root of 1,005 using calculus without a graphing calculator. It's an approximate. F of x, but f of x is f of the cube root of 1,000. So this is 10. F prime of this, so this is positive 1/3, the cube root of 1,000 squared times dx, which is 5. So I only filled in the formula. I didn't do anything else. The cube root of 1,000 is 10, but I have squared. So this is 10 plus 5 over 30. And I'll simplify, and I get 10 plus 1/6. Remember, 61 over 6. 61 over 6 is the same or very, very close to the cube root of 105. So we go to share, and I'll stop right this moment just to show you 1005 carried to the power 1 divided by 3. I didn't mean that. Okay, so 1005 to the power. I prefer this, but you can use the math. Okay, and 61 over 6. So this is extremely powerful.